Okay, so first these three things: integration, delivery, and deployment. So when we're talking about continuous integration, it just basically means that you are able to compile your code and integrate your system together at least on a daily basis, and that's it. If you're doing it, you're doing basically continuous integration. When you add to it a piece of text, which piece sounds innocent, but the thing is that if you are sure that the package you produce out of the pipeline, after the pipeline is fully automated, so the package that is produced by the pipeline, if you're sure that this package is okay to be deployed on production, it does not have to be deployed in production. It might be a separate business decision to deploy it or not. It does not need to be deployed on production. But you feel okay, you feel comfortable with this particular package to go on production, then you're doing continuous delivery. You continuously have something to deliver, okay? And the last piece is just a cherry on top, which means, okay, I have a pipeline defined, I just push my changes through the pipeline, and at the end, it ends up on production right away. Right? Just like that. That's the last piece. That's the continuous deployment. What we'll be talking about here most of the times is continuous delivery. And how to go from continuous integration. I assume that that's a foundation. You need to have it, basically. Nowadays, in the 21st century, we all use CI, and we all probably have CI. So I won't focus on this. I will treat it as a given. We have CI. We just want to go towards continuous delivery. And then I will talk a few words about deployment if time permits. Okay, so why should you care? Classical situation in most of the companies that I've done trainings for looks like that. There is a separate automation testing that do the end-to-end test automation, right? Most of the time Selenium. And these guys, they produce hundreds of tests. And the problem with these tests is that they are lengthy, right? They take much time. And we soon end up in a situation that we have builds that last for 4, 8, 5 hours, I don't know, something like that, right? And we end up having so-called nightly builds. So what happens is just that every day we come to work and this nightly build most of the time fails, or at least, I don't know, 50, 30% of times it fails. And right now we just start making analysis. Okay, so what went wrong, right? But these tests are not really precise, right? They are just end-to-end tests. So you have huge amount of things to analyze, because during the previous day there were a bunch of developers that were committing changes and they could have broken everything, right? And I just need to spend some time on analyzing what went really wrong, right? So by the time I know it, it's probably just before lunch. So I just, I know who has done the change. I know the person because I've checked what were the commits and who were committing in this particular module. That's the problem. I just go to the person, but the person probably just went for lunch, right? So you just communicate to this person right after lunch, and it's already 2 p.m. or 3 p.m. and you're doing it, okay, but this guy is actually right now doing something else, right? And it's totally out of the context. Or maybe he will tell that, oh, yeah, but you know, we've just changed the IDs in the GUI, and yeah, of course it will fail, but just change it in your test and that's it. And it should be fine. Actually, that's not a problem. And so these are the problems that we have. And then instead of actually feeling that we are creating something good with all the other colleagues, developers, we just feel as being a troublemakers, who just go and chase the others, right? Who has introduced some bugs. So the goal here is just not to allow for this change to enter the master in the first place. Right? So I don't want to spend whole day of analyzing the build, finding out that there was just a GUI change, I don't know, some ID change, whatever. I want to prevent such change to be committed to master. And that's the important stuff here, right? Okay. How to achieve it? So basically, let's just think about the things that we need to have in order to have the continuous delivery. So first of all, we need to be able to build our environments in an automated manner. The project I'm working for is based on Gigaspaces, which is a kind of a cloud. So in order to deploy my project, we just need to deploy certain amount of containers, and then in these containers we're deploying our application, actually, which is written in a microservice way, so there are a couple of components that we need to deploy. So the thing is that first thing that we need to be able to do is build our environment in an automated manner. And here's the important stuff. I need to be able to build this environment in the same way on CI environment, on demo environment, on UAT environment, and on production. The same scripts, exactly the same scripts, should be used to create these environments in all these places. The only thing that would be different is a configuration of the script, which is okay, right? So that's the first thing that we need to have, which is we need to separate the way we create an environment from the way we configure the way we create an environment, right? Okay, so we have it, and it lives in a code repository, right? So we have this one. Okay, so now we have the environment built. That's good. Another thing that I need to do is I need to have a way to deploy my application in an automated manner. And here's, there is a tricky part, especially for those who are working in a product companies, which is I need to have an installer which allows me to install the product in a silent way. Right? No one will be just clicking something. Right? It needs to be fully automated. It's a silent installation. I just deploy it. Okay, automatic. Great. So I have a way, and again, of course, the same rule applies. I need to be able to deploy it, my product, in exactly the same way on each environment. Right? So I do not have a different procedures how to deploy it on UAT and how to deploy it on pre-prod or prod. Of course, configuration will be different, but that's just a configuration. Right? I just point my scripts to one server or the other, but basically the steps, the algorithm for deploying application is the same. Good. So I have it. Another thing that I need to have is a set of tests. So we've heard a lot about automated tests, and what I have in mind by saying tests, I mean all the tests that you want to do on this particular package in order for you to feel comfortable that yes, this package may go in production. And this whole suite of tests needs to be automated, which is unit tests, integration tests, end-to-end tests, performance tests, I don't know, whatever tests you else there have. Whatever you have needs to be automated and needs to be part of the pipeline. Okay, so now let's just take a closer look how a pipeline looks like. So first, a high level. Every change I'm doing to the code, every single change, I create a pull request, which is a request to pull my changes into the master. These changes are not yet into the master trunk, right? I just create a request. Please pull my changes in. And just by creating this pull request in Git, this pull request, so-called, triggers Jenkins Pipeline, which means that my changes are being pushed through all this pipeline, through all these tests, unit integration, system, performance, security, whatever you else have. All these, my changes are pushed through this pipeline. That's one quality gate. And the other quality gate is that these changes are being reviewed by the other pair of eyes. Actually, in our case, it is always at least two pair of eyes. Because it is a one person from my team and a person from the other team that looks at my changes that I've introduced to my code. So it is Jenkins who proves that yes, all the regressions you passed, everything is cool. But also from the meritorical perspective, we check whether our changes are okay, right? Good, and of course we do not commit any change to the code unless we have tests for it, right? So BDD is there in place. TDD, all these three letters, acronyms are there. Good. So then there is a pipeline. Once my all tests are passed and reviewed passed, then the person clicks merge, which is okay, good, this change is fine to enter the master. And now pipeline is triggered again. Because right now I'm integrating the changes into the master, and possibly there are some other changes, so I just need to check whether there is no interference, right? Gives you a certain amount of, let's say, it assures you that there were no merge conflicts, but just to be sure, we just push master through pipeline again. And as a result of this pipeline, we have a package that is totally deployable in production. And you know what? We've introduced continuous delivery March this year. And we have monthly releases. And in fact, I was preparing the release this week because it's end of September, we have monthly releases, so we're preparing a September release. And the question I received from my prod services was, okay, so it was like a week ago, so when do you plan to have a code cut? Do you know the term code cut, right? I just see one head nodding. No, okay. So code cut basically is a concept that, okay, I freeze the changes. Right now I do not do any changes in code, and I'm doing so-called hardening iterations, right? So I'm just checking whether it really works, whether it is ready for production or not, right? I just freeze the changes, and now I'm just doing some late testing. And then after this testing, I'm sure, yes, it's okay to go for production. So that's what code cut is, basically, right? So freeze of change. And 6 months after introducing continuous delivery, he just asked me a question. When do you have code cut? But dears, there's no concept of code cut anymore, right? It's just that every day, at least I've just counted there, 5 times a day, I have a deployable package. I do not need to have a code cut anymore, right? It's just that whatever day you ask me, I will just give you a package that is that has all the features, that is the newest package, and is ready for production. And you can deploy it, just go ahead. Right? So there is no concept of code cut anymore. Good. So now let's just do a deep dive into this Hexagon. How does it look like? How does Jenkins really look like? And there is a nice plugin which is called a delivery pipeline plugin. And what is nice about it is that it is a fairly flexible. So it's just a visualization plugin, right? Under the hood, these are just Jenkins multi-jobs, nothing more, really. I will just show you what is the structure of the multi-jobs in a moment. But what can we see here? Here's the beginning of the pipeline, right? So here my changes enter the pipeline. And the first thing I'm doing is that I'm invoking or I'm triggering static code analysis, unit testing, integration testing, and I'm building the package once. And that's the issue we had at the beginning when we started our adventure with continuous delivery, which is we were building new packages over and over again for all these builds because it was easier from the Jenkins perspective. But the problem is that then you're not really sure whether the package you will create for production is really the same that the one that actually will pass through tests, right? The only thing you are sure is that the code is the same. But to create a package, you might have different compiler. You might have different Java version. You might have different optimizations of the compilation. It all may matter. So the core thing here is you build the package once. And once you have the package, it is a mythical hero that just goes and slays all the bastards that are on his way, which in this particular case are the system tests that it needs to just pass through, right? So it's just that I have a package here, and then as you can see, there is a bunch of system tests that I push the pipeline, the package through, which means basically I just take the package that is built the same way it should be built for production, right? It's just one package. I deploy it on my CA environment, and I just run system tests against it, right? There are various types of system tests. This particular package just contains 4 different modules or 4 different small microservices, and I test all of them. Once it passed this stage, verification stage, there is also so-called additional verification, which is for our case. In our case, we just do their performance tests, and that's our room for improvement. Because we had to do it, let's say, slightly aside. Right? These dotted arrows here, they show all the manual, all the builds that needs to be triggered manually. Why we've decided to push it aside? Of course, time. Right? So these tests needs to be run in a serial manner, right? So one after another, because we have only 2 servers that we can employ at one time, and there is only, we can only run one test. So all these tests needs to be run one after another. Each takes approximately hour 45 minutes. So altogether we have over 2 hours. And the thing we did not want to have is just that we will wait additionally 2.5 hours before we are able to deploy this change on UAT, right? So these builds, right now we're working on pushing the time down. We've already managed to push it down to 15 minutes, which is cool, but still it is, since there are 3 of them, it's 45 minutes, still a huge amount of time. Anyway, so far it is just that, okay, once the verification passed, these tests are automatically triggered on daily basis, right? So in the night, it goes one after another. So there is no way that we will push a package that did not, that was not tested from the performance perspective to production. It is possible that we will push it to UAT, but not to production. Okay, so once the verification step passed, then we just go to promotion, right? It is just that we do not, what does promotion mean? It's stupid simple. It just takes the package that is built here at the first step, that resides in the CI repository, and just uploads it to the Nexus. That's it, to the public repository. That's all it does, nothing more. It's just an upload, right? That's it. Okay, and then once it is deployed to the public Nexus public repository, then we are able to deploy this particular package on different testing environments. Why we need to deploy it on testing environments, right? We have a pipeline, because not everyone has a pipeline. And we have, as I said, we are the gluing part. So there is in the bank, there is a UAT environment, and lots of tests of other applications are being run there, and we need to be able to just deploy it there, right? So that's how it is. So we still deploy our package to UAT environment. And there is one thing I wanted to touch, which is versions. How many of you know what is semantic versioning? Okay, just 3-4 hands. May I have some? Oh, here is something. Right. Good. So basically the version is like that. Right? So 1.2.3. And what the semantic versioning tells us is just that that's a so-called major version, that's so-called minor version, and that's so-called patch version. And the definition is, if I'm changing, or if I'm only fixing the bugs in my application, I'm incrementing the patch version. Right? So it would be 1.2.4, 5.6. If I'm adding a new feature, but I do not break the backward compatibility of my service, then I'm incrementing the minor version, right? If I'm adding if I'm changing the API of my service and I'm breaking backward compatibility, then I'm incrementing the major version. In our case, it is just, we do not have patches. So we have only 2 versions, which is one, we treat fixes actually as just features. So there are no really bugs. That's nice, right? And, but honestly speaking, there are not, we didn't have any production issue. Really. No, it's just that we are really close to our production services. So it's just, yeah. Anyway, the thing here is that this part, by default, it is set by by our continuous integration server, which is just a build number, right? You can see it here, which is the version, it's 18.631, which means that we had from March 631 pipelines went through, which gives on average 5 pipelines a day. So on average we have 5 packages a day ready to be deployed in production, mostly because sometimes pipelines fail, right? So that wouldn't be a purpose of pipelines if it wouldn't fail. Okay? And there is one other thing. I told you that we have a platform that we need to use, and on this platform we deploy our packages. There is also information about the version of the platform that we used to test this particular service. Right? So then we can ensure that, okay, we need to ensure that in production this version of platform will be used and not something else. Okay. Let's just go on. So from the Jenkins perspective, as I told you, these are just a multi-jobs. So basically, this trigger is a multi-job that holds the unit integration test and this pipeline verify artifacts, which in fact is just a multi-job that holds all these tests. Right? So you can see on this slide that that's the ESC pipeline, right? That's the root of all the builds. And then that's another multi-job that holds all the verification tests, and here are just the unit and integration tests. So this is basically just a hierarchy of multi-jobs, and that's it. Nothing fancy here, really. But what is the ramification of this approach? Is that I already told you that each commit actually goes through two pipelines, or goes through pipeline twice, which is that we need to run all these tests in our executors. It's just basically consumes our resources. So here's just a hint. We've done it as an improvement in our environment. We've divided these builds into two categories, which is trigger builds, because trigger does not do anything except it monitors all its child, right? It doesn't do anything more. So we have one pretty weak server that has 10 executors on it, and we only run triggers there, just in order not to consume the heavy machines that should be doing real job, and not just monitoring whether children are done, right? So that's the improvement that we've done. So there are triggers run on one machine, and then real jobs are running on other servers that have only 3 executors on them. Okay. And pipeline dependencies. Good. So first rule is, do not introduce pipeline dependencies, basically. And I would say that there are two ways we can avoid having pipeline dependencies. So in our case, as I told you, it is just, there is a platform, and then on this platform we are building our microservices. Good. And that's a platform. That's microservice. Good. So the thing is, if I introduce change here, I may make my microservices to not be able to be deployed on my new platform. So one way would be, okay, so if I'm doing the changes in the platform, then as part of this pipeline, I'm just triggering the pipeline of my microservices and just ensure that, okay, these microservices, this pipeline of my microservices goes on this new platform, and then it's proven that, okay, yes, this new platform is the same, but it takes time. And if we just think about what Tomek said a while ago, about 200 microservices, and you just think about amount of pipelines we would have to trigger, that's just a obviously wrong direction. So what we rather do is just that, okay, when I'm doing changes to platform, first of all, of course, I'm checking whether I'm able to deploy the platform. Yes, I am able to deploy. Then I take the newest published version of my microservice that is already on the public access, and I just deploy it on my platform. The assumption is, I've done a change that I think is not breakable change, right? It did not break the backward compatibility. So if I take the newest version of any service, it should be deployable on this new version of platform, right? This way, in the pipeline of platform, I am able to ensure that I did not break any contract that I have with my microservices. That's one. The other thing is just that what Tomasz said a while ago, which is two microservices talking one to another. We can think of it as just, okay, so there is a reporting service and a business analysis service, right? That basically requires a feed from the reporting service. So if I change the API here, right, I just need to be sure that I did not break the reporting service, right? Because I'm changing the business analysis service. So how do I ensure that this change does not break the other service. So again, one solution is just to trigger its pipeline, deploy the services, and see whether everything works there. But no, we already know that that's not the direction. Tomasz was talking about the consumer-driven contracts, right? So what we do actually, we just introduce a piece of thing in the middle, which is a contract, and we test our microservices against this given contract, right? So it is the contract that is that defines, okay, what is the API, what are the expected responses for a given request, and then we're checking whether, okay, let's say that report has some REST API, right? It just gives us the REST API. So in the contract defines, for this given input, that's the response. So I just put in this response into BA, business analysis, and I'm just checking whether business analysis microservice is able to process the response. If it is able to process, okay, fair enough, the contract is safe, right? It just might change it, not break it, which is good. So again, we just do not go into integrating pipelines between each other. Okay, if for some reason we're not able to do it, then the suggestion is to classify your dependencies in 3 ways, which is a static dependency, fluid dependency, and guarded dependency, which is static dependency means that, okay, this business analyst microservice depends on, let's say, 1.1 version of the reporting service, right? So that's a hard-coded static dependency it has, right? We know that it should be working with this version. So if I'm changing the reporting service, then I'm incrementing its version, that's obvious. Then one thing is just that I'm sure that it did not break the business analysis microservice, right? Because it has a static dependency again against different version. But anyway, I can trigger the pipeline of the, I do not have contracts here, right? So I just need to be able to deploy this new my service and this BA service and just run the tests of the BA service here, right? Then if it works fine, then it is cool. If it does not work, then I know that I've broken a contract between reporting service and business analysis service. Right? It's just a matter of a fast feedback. Okay, but the production is not broken. When fluid comes into place, it just says that, okay, BA service depends on any newest version of a reporting service that is higher than 1.1. Right? So if I change it, then BA service will automatically just push the newest version from the report. And here, it's not that easy, because then again I need to trigger the pipeline of the BA service. But if it fails, then I fail my changes as well. Right? It's just that my build fails because I cannot introduce this particular new change because I've broken the dependency to that BA service has upon me. And what happens then? This dependency that was fluid so far is being downgraded to the latest known good version and is marked as guarded. Right, so I'm saying that, okay, so from now on, let's say that I've just introduced 1.2, it worked fine, and I'm introducing 1.3 and it broke the BA pipeline. So we're saying, okay, you just go back to 1.2, that's the version that BA depends upon, but I just mark it as guarded. Which from now on behaves as a static, but it basically shows that there is a problem. But just to be clear, let's basically not go towards pipeline dependencies. Let's just get rid of them as fast as possible. Let's basically just don't go towards this path. Okay, and zero downtime. So let's say that I want to do a continuous deployment. Right? So what does it mean, continuous deployment? It means that each change ends up in production. But imagine that you're using a service and 5 times a day, right? We have 5 times a day a package that is ready to be deployed on production. So 5 times a day, we just see a screen which says, oh, maintenance mode. Sorry, my dear user, we cannot use this service, right? That's a problem. We just cannot allow to have such situation. So there are certain ways how to approach continuous deployment. First is so-called a blue-green deployment, which basically means that we have 2 production environments, right? First, let's say green is operational environment, right? So that's the environment that my users use. When I'm deploying my application, I deploy it to the other environment, which is blue environment, right here. Let's just forget about data migration. Let's just say that for now I'm not changing database schema, so it is okay to deploy my application here and attach it to the same database. That's fine, right? I need to, of course, disable some listeners if I have there. That's the architectural challenges that I've talked about. But the thing is that, okay, I'm deploying the application here. So an important thing that we need to realize is that we are distinguishing between deployment and release. That these are 2 separate concepts right now. We can deploy a product into environment, but production environment, but it is not yet released to the public. Okay? So here, version 2 is deployed, but not released. And then on some load balancer, or I just switch it. Right now, it goes, the whole traffic goes to version 2 of my product. If something goes wrong, I can put the switch back to my green environment, right? So this actually prevents me from having all these maintenance mode screens. Of course, there are certain challenges, because what will happen if, let's say, I just switched to blue environment, and I've created some transactions in a new way. Okay, maybe not a new way, because we said that there is no schema change, but an invalid transaction. Right now I have inconsistent data. And it's a problem to switch back right now to the other service, because I've basically spoiled it. Right? So that's a challenge we need to face. The way how we tackle these problems are compensating transactions. Right? So if we have such problem, so first of all, we need to have a so-called semantic monitoring on production, which basically, or we need to have tools that would detect any inconsistencies in the database. And once we have them, we need to have a way to create a transaction, compensating transaction that would revert the previous transaction, which is challenging in certain situations. Anyway, another way to do a zero downtime deployment is a canary deployment, so-called canary deployment, which basically means that I again have two environments, but right now I'm just not switching whole public to the version 2 of my application. I'm just switching subset of clients, right? Just few clients, and then if everything is fine, then I just switch it to the entire population of my users. The way they've done it in Facebook is that there are basically 3 stages, which is first we deploy it for our employees, then we deploy it to a small subset of our users, and then if everything is okay, we deploy it to everyone. And there are certain patterns how to do it. So first is a expand and contract pattern. So basically, the idea we have here is that every change needs to be non-breakable. I mean, every change that we do to our services cannot break the other services that are in our environment. So the question is how to achieve it. So first example, let's just think about it, is when I want to change my API. Okay, so I have a service that has API 1, and I want to end up in a service that has API 2. Certainly breakable change. So the only way I can do it, and the rule of thumb is, I should always be able to have to make a one step back, always. Just when we're just switching, right? It needs to always be safe to switch back and forth. So here, in order to introduce this change, we need to have an intermediate release, which is FP1 with API 2, which is called expand and contract pattern. So basically, first we expand our API, then we migrate all the consumers of our API 1, so they use our API 2. We mark this API 1 as deprecated. Once we do not have anyone who is using API 1.1, we have yet another release that actually cleans it up, right? So we just remove API 1.1. So you can see that every time I can take a safe step back, every single time here, right? So that's a simple case when we add an API here. But there is a more complex case when we change a database. So let's just think of it. How much time do I have? 5 minutes. Okay. So let's just think of a situation that I had a simple table, which is it just has some ID in it and a name. And what I want to end up with is a table that has ID, fair enough, but it has a first name and a second name. Again, clearly breakable change. Right? How to approach this particular case in such a way that it will be possible to deploy it continuously on production. It requires 5 steps, which is, first of all, first step is that I'm changing the schema of my database in such a way that it supports both formats. So I have a table, ID, name, first name, and second name. And of course, here there is a constraint which is not null. And here is also a constraint which is not null. That's my end state, right? And here also not null. So here, first step is that I still have name that is not null, but I've added 2 additional columns. That's first step. Second step is I'm adding microservices, my services that actually fill both structures, name and first name plus surname. Why? Because in my environment, there are still services that are using only name. So my service needs to fill both. Right? And it reads from either first name and surname if it exists. If not, it has a fallback to the original, okay? To the original column. Another step is, okay, I'm migrating all the services that are filling both structures, right? Name and first name and second name. Okay, good. So now I'm in a position to actually migrate all the data from name to first name and second name. Right? So that's what I do. Migrate. Name to first name plus second name. Got it. Now I'm in a position to actually deploy another version of my service that actually reads only from the first name and second name because all the data is there, right? First name plus second name. And the 5th part is just that finally I am able to remove the name column because no one is using it anymore, and I'm able to add these constraints here. The bottom line of this whole thing that I've drawn here is that it is expensive. So whenever you are thinking about going towards continuous deployment, it is an expensive solution. Okay? And this whole thing that we talked through today, this whole continuous delivery, is all about pushing things from quality control to quality assurance. I do not want to treat my tests as a quality gate for the software. I don't want these tests to be finding bugs in my software. I want them to be finding bugs in my process so I can improve my quality assurance process so the bug do not reappear. Thank you.